Welcome back to Advent of Code. Today is day 8 and I am super excited because, as you can see with this problem statement, today we are writing something that parses assembly code, some kind of language that we have to parse in order to make a program run. So this is a program written in a specific language and we're going to pass it in order to make it run, which is super exciting. As always, we just start by copy pasting that in here. Oh, one thing though, before we proceed, there is an infinite loop somewhere, which means that this code is running forever and we just have to detect this and stop, and we have to return the accumulator. So because I've completed last year, I did like a couple of changes from last year. I remember that this kind of stuff was reused quite a lot of time. So here we're going to create a class program like right away, because most likely this is something that is going to be reused. So this is quite important. And first of all, we have an accumulator. So let's just say this accumulator, I believe it's initialized to 0. Let me double check that. Yeah, I think so. I think that starts at 0. Yes. So this, then here we have our code. And actually, let's just like do that right away. We're going to have the lines already here. So here we can say new program of lines. That's going to be it. That's going to be all of our lines. Now we need to pass this. So not a problem. Here we're going to have this .code. Oops, actually, we're going to set here this .code, and we're going to use the lines and we're going to map it to parse each line. So what do we do here? We're going to use regular expression, of course, because we have a string and we need to extract some value, so it makes a lot of sense to use a regular expression. So I think each of the command is a 3-letter command. It's hard to say. Actually, let's not take into account the length. We're just going to be saying that we have something that is not a number several times, then a space. So this, we want to capture that. Then we might have a plus. However, a plus is a specific character, a special character in regular expression, so we have to escape it. And then we have maybe a minus, and then we have one or several integers, and we use the parentheses to capture this and reuse it. And we're going to be naming the capture group, because you know I like to name the capture group instruction, and here we're going to call that just value. And we're going to run this regular expression. I think we can just make sure this is capturing everything. And we're going to run that on line. And we know that this is going to match, so we can use const group like that and return group. We're going to check that right away by logging p and check what's inside this. So we have to run this program for the first time. It is super exciting to write that kind of stuff. Oh, this is null. Let's log here line. Oh, yeah. Okay, I'm still passing day 7. So I want to pass day 8 here. And we can remove this now. And the code here is not the right stuff, because I believe this is groups and not group. Now it's containing everything that we care about, which is the instruction and the value, with minimum, with minus something. So maybe we want to do, what we want to do is to say groups.value equal parse int groups.value. So what we do is we make sure like this is an integer and this is a string. That's gonna make everything super simple later on, because most likely this is gonna be reused. So usually when you have that kind of stuff that you want to interpret, you have to have a pointer to know which instruction you are at. So we're gonna call something this.pointer, and it's gonna start at the first instruction. So we're gonna start at this instruction. So here, when they say these instructions are visited in this order, this is the pointer. The pointer is starting here, then we go to line 2, then we go 3, and then we go to this line. So this is good to have this pointer. Now, we need to understand each of these instructions and make the right stuff. So nup is no operation, it does nothing. So this is the first thing that we're going to do. Actually, we're going to create a function run that's going to say, for now we're going to just do like an infinite loop. That's a bit dangerous because we know this is a program that runs forever. And here we're going to say const instruction is equal to this.code of this.pointer. Actually, we can say instruction and value. So basically, this gives us the current instruction and the current value. So if this is nup, so I think we're just going to go with a switch case here. Maybe there is like, yes, perfect. I like when the IDE is already providing you like some nice syntax. So we are going to switch on the instruction. And first of all, we want the case for nup. Nup, it is simple. We just do this.pointer plus plus. That's it. We don't do anything else. It's quite easy. Then we want the ACC, which is increasing or decreasing by the given argument. So let's do that. We just copy paste this. Here we're gonna go and throw a new error, not implemented. And here we want the accumulator. What we're gonna do is we're gonna say this dot accumulator plus equal this value actually. So in the accumulator, this is something that is in the program. We take the value, we just use the current value and we add this value to the accumulator, and we should not forget to do this then pointer plus plus to make sure we go to the next instruction. We're going to be running that. I can remove the break because it should break on the not implemented. Let's do p.run. Oh wait, p.run. I think it's best here to do a log as well. Instruction value. Yes. So here we had nup 0, ACC 1 and jump 4. So these were the first three things. And jump, JMP is jump. That is an instruction to jump to another part of the program. Okay, jump plus 2. Okay, so let's do that. So basically here, because we have everything coded like quite nicely, it's going to be quite easy to set up this jump. JMP, this is an instruction that messes with the pointer, and we're just going to have to do pointer plus equal the value. Because everything is parsed correctly, it is super easy. Here we just have to say jump to another instruction. So let's just make sure plus 1 it would continue to the instruction immediately below it. So that's it. This is it. This should be our first or like complete implementation. And here, if we run this, this is going to be running forever. And this is actually, let me stop. I can't stop using, okay, this is stopped now. It was scary. So here there is an infinite loop that they are already mentioning. So now we are going to make something to avoid this infinite loop. And what we're going to say is we're going to say this dot run. No, we need to come up with something. Done. We're going to create a set here. Set is really nice because you can say which instruction has been already run. So here we're going to check if this dot done has this dot pointer. We need to stop here and say, okay, there is a loop. So here we're going to break. And the break here is breaking outside of the while. So yeah, this is not really awesome because there is a break here that is breaking outside of the switch, and here the break is breaking outside of the while. So I would advise against doing this, but here in our particular case, I think that's fine. That is fine, yes. Maybe we're gonna split this into a separate method. Yes. Execute run line. Yeah, we're gonna do that. Pointer. We're gonna do that. You know what? I think that's fine. I think that's fine. So here, if there is the pointer already in the done set, then we break. Otherwise, done dot what do we have to say? We have to set it or to add. Yeah, we have to add this dot pointer. And what do we want in the end here? We want to check the value of the accumulator. So here we're going to console log infinite loop, and here we're going to put the accumulator. So by the way, this is a nice trick. When you're doing a console log, you can put curly braces around a specific variable, and you will see that it's going to appear nicely. Oh, yeah, damn it. So my nice trick won't be useful. But basically, if you that would be, if you have a variable, it's good to put curly braces because then it's easy to read. You know, it's really to say that okay, the accumulator has for value 5. That's a little trick. So here I've just removed the console log. I think we should remove another console log here to make sure this is very clean. And here we have our infinite loop error. That's perfect. Time to get the full puzzle input and run it. I think here there isn't really like a bad thing that can happen. This is the accumulator. We have to put the value here. That's good. Let's go to part 2. Part 2. There is one instruction that is corrupted. That's not cool. There is a jump that is supposed to be a nope, or a nope that is supposed to be a jump. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. I don't understand this part, by exactly one jump and nope. Okay, so here this is interesting. We have to change a jump into a nup. So 1, 2, 3, 4, 5, 6. I'm afraid there is several ways to solve this problem. So we're gonna see. But that looks a bit more complex. Fix the problem that it terminates normally by changing exactly one jump to nop or one nop to jump. What is the value of the accumulator after the program terminates? Okay, so here we should never touch the value next to it. We should just touch the thing here. That's interesting. And here we need to, that's going to be a challenge here. So I think this is clear. This is approximately clear what we're going to need to do. We're going to need to check here if the next is a loop. And if it is a loop, we're going to need to change it into a jump. So let's do that. If the next step has this dot pointer, so what we are going to do here, we're going to check if the next step has, you know what? I think it's time to add also something here, some options. And here we're going to say options, this dot options equal options. And I think that's going to be really useful because we're going to be able to reuse our code for both steps. And here we're going to do something like that, where in the option we're going to say fix loop true. So basically we're passing a flag and we're going to run this code only when this dot options dot fix loop. So we're going to run this piece of code only when we need to fix the loop. Hopefully that's going to be fine. No, not hopefully, we're gonna make this work. So here we say if the next step is to go to a loop, then we should instead do this dot pointer plus equal value. And here we're gonna do something else. So basically what I'm attempting to say, right before the loop, we are transforming the nop into a jump. And here we're going to do something similar. We're going to say if this pointer.value is a loop, then we're going to say this dot pointer plus plus and break. So I'm not really focusing on the part where we need to modify just one instruction. I'm just trying to attempt this. So what we could do is, so I'm not sure this is a good way to fix it. I think the better way to fix it is to attempt to modify each nop or jump. Let's do that instead. So we're going to forget about that. We're going to forget about that. This could have worked, but I think this is not clean. We're going to keep the option here. We're going to set by default an empty object, just for the future. So here what I'm thinking is we're gonna create a toString method. You'll see that's gonna be a bit interesting, but that should be good. So we're gonna return this .code. Several modifications that we're doing. Here, instead of reading the lines, we are going to be receiving as an input a full string. So here this is a string. We split and we filter, yes. And here we want to output a string. So here we want to this.code.map. We return x.instruction with a space and simply x.value. Let's check this out. We're gonna console log p.toString. Oh yeah, we should go back and reuse this small example because this is going to be a bit heavy to do this second part. So we want to always use the test case while we're debugging. Okay, so that's not what I was expecting because I missed one part, which is to join. Now we have a list, an array, and here I want to join with a line return. Is that the right way to go? Let me do it like that. So what we're going to do is we're going to go over each of these lines. So I think we're going to call that 2 lines so that we have an array. And now what we're going to do, we're going to say for in. We're going to do a for in for oh, I don't like the for in. Let's do a simple for loop. Index I in this p.toLines const int code so we're going to check here and we're going to need to run this several times. So here we're going to const a new program p fixed new program and we say if element, you know what, let's just return here. We don't care about the lines, we just need this.code. Actually, let's make this simple. I'm gonna check if element dot instruction is equal to nup or element dot instruction is equal to, actually let's put a 3 equals, that's always better. If this is equal to jump. In that case, and in that case only, we create a new program, const fixed program, and we need to change actually the code here. So we're going to say element. Okay, so one thing that I'm worried here is that I'm getting the code from the program and I don't want to override this code here. So we need to make a copy of this array. So in doubt, const copy, I just do a JSON parse JSON.stringify. That's maybe something that we want to fix later down the road, but for now, I'm just like not sure exactly how I'm gonna solve this. So we make a full copy of the code JSON object. This is a bit slow, but it works, you know. So I think here today we want to make this work because I don't think the program is going to be, we're going to fix the program in the next days. Let's do that. Now that we have our copy, we can convert that into a string, which means copy.map, and here we want x.instruction and x.value, and then we want to join that with a line return actually. So I think I've done a bunch of stuff here, and we're gonna need to log stuff because we don't want to go too far. We want to debug that a little bit. One thing that I want to do with this copy is I want to do copy of I, and I want to change a nop into a jump or a jump into a nop. So here we're going to say if this is a nop, in that case, okay, we just want to change the instruction. So we just say, okay, copy.instruction. If the instruction is a nop, in that case we put jump, otherwise we put nop. So what this line is doing really is that it is just replacing one line from a jump to a nop, or a nop to a jump. Then here we are creating the program, and we're going to be displaying that. Okay, I need to say program. I need to say something because there will be like several different programs. And here, if we check this jump here should be replaced by a nop. Yes, that's correct. And on the previous program, this jump here, -3, should be replaced by a nop. That's correct. Then this jump 4 should be replaced by a nop. Jump 4 is replaced by a nop. And then the last thing is replacing this nop by a jump. Yes, that is correct. So here we are generating all possible fixes from the program where we replace one and only one instruction. We have our new code here, so we can create a fixed program, const new source, so it's the new code here, and this is what we are going to pass in here. Remember, this is a string that is split, so we can pass a string that is joined. That is correct. What now? Now we need to check if the fixed, we need to run this fixed program, and let's do that. We have 1, 2, 3, 4, 5 issue where there is a loop. Oh wait, I need to run fixed program. This did not work. That's one thing that we need to be careful of. So that's actually, I think, the right stuff. When the pointer, we need to check if this dot pointer is exactly equal to this dot code dot length. It means that we have reached the end of the program. Console. Oh, so what I want to do is to set a boolean. This dot is finished equal false by default, and here we can say this dot is finished equal true, and we are going to break, and let's run that again. We shouldn't have any issue here. That's correct. And now we need to check if fixed program is finished. In that case, we can console log something. For part 2, what do we need to console log? The value of the accumulator when the program terminates. So we have to do fixed program dot accumulator. In that case, we see our different infinite loops, and then we see that when the program has finished, the value is 8. So now we need to get the full input and run that. Hopefully. Okay. One thing that's a bit annoying is that here we are like writing this infinite loop. So in order to fix that, loud infinite I cannot write infinite loop warning true. So here we're just gonna display that if infinite loop this dot options dot infinite loop warning. So yeah, that's a little trick where we pass an option object and we're gonna be able to have some flags in our code for the different scenarios. Now if we run that, we see that for the part 1 we have our infinite loop warning that is displayed perfectly, and here the value of the accumulator that we're gonna paste here. And it is working! Thank you very much for the support in this series. Please drop a like and see you in the next one. Bye bye.